who or what got you motivated to start a career in natural sciences?
Actually, for me, that started quite late. So in school, I didn't have a special connection to science, actually. So that career path was not clear from the beginning. So after school, I studied economics. And it was later, after I've studied several semesters already into economics, I started reading popular science books from Heumann from Ditford, and that really caught my interest. And there I realized that I had to change the subject, and then I switched to physics, and I've never regretted that. So that was the best decision I have made.
For me, it's very simple. My parents, both of my parents are scientists, biologists, both of them. And since a kid, I had, science magazines at home, which I could read. And I was always fascinated by science in general, biology, physics, chemistry. And at the end, I opted for physics.
Yeah, I think as a kid I always was interested in biology and everything outside and all the animals. I had a microscope as a kid. I mean, chemists usually have this molecular toolbox, but I looked through the world of a microscope.
So I think it was actually my father. He's a teacher in Spain, and he was teaching natural sciences. And since I was a child, I remember we used to do little experiments at home, and I used to help him prepare his classes. And later on, I wanted to become an astronaut, and that was the reason why I studied physics, until I realized that I get very seasick, and then I decided that I should do something else, but really my space career will be very short. So I finally studied physics, but I did a specialization in solid-state physics.
And at what point in your education did you realize that you wanted to become a professor?
So like every physicist student, I had no idea what I'm going to do. I started studying because I found the subject interesting, and I didn't think too much of what I would do later. And in the end, I did my diploma in physics, but my PhD already in chemistry. And now I'm a professor for chemistry, and that I wouldn't have never planned in the beginning. So this means you shouldn't, this is at least my feeling, you shouldn't be too sure about what you're going to do or too limited in what you are going to do, because you never know how things are going to turn out.
This is difficult because what I always wanted to be is a researcher, to be a scientist. And you don't have many possibilities to be a scientist, or you stay in the academia as a professor, or you work in a, let's say, institution like Max Planck. And in my case, I had the possibility to stay in the academia, and it's something which I do not regret. I still have a lot of fun working as professor here at the Technical University.
I think usually you cannot really plan it. So my PhD advisor already told me that's a path you cannot plan. It's a lot of luck also involved. So I just can say maybe more or less it happened with a lot of luck, but of course with a lot of enthusiasm and work.
This was actually later on when I was a postdoc in Santa Barbara. I was in California in a chemical engineering department, and I had two office mates that were there since a couple of years. It was my first year, and they were all applying for faculty positions. They encouraged me to try the same. I thought it was very early, but it will be a good experience just to write your own science proposal and go for interviews. And I was not actually thinking that this is going to work out the first year, but it worked out. So I got my first position when I was 26, and I was at the University of Central Florida in Orlando.
And during those different phases, did you also consider other career paths? And if so, what were they?
I might have become a teacher if science wouldn't have worked out. But luckily, I never had to think too much about this, but I'm sure I would have found also another fulfilling job.
Yes, and this is very difficult. Now, sometimes when you don't know, I mean, we all know that to get a professor position in Germany is very difficult, especially if you're at a certain age. And at some point, you have to decide whether you continue or not. And at this point, that was, again, when I was doing my junior professor position, or when I had my junior professor position, that I had to decide whether I stay in academia or I completely change, like, for example, do some teaching or go to an industry or do something completely different?
I think, of course, you have to, but I mean, since I always liked to work also, I like to work in the lab, that I always thought that, I mean, there will be another job in science. I did not consider anything outside of science.
So it all happened very fast. So I studied physics faster than normal. Then I moved to Germany. I did my PhD here in solid-state physics, and I was always very interested in research, and so I knew that I wanted to continue in research, whether this will be in a company or in academia. This came later on when I got my first position as a professor. Then I just continued on that path.
What influence did your PhD thesis or your topic have later on for your scientific career?
It might be very important. In my case, it actually wasn't, because after my PhD, I switched topics again, switched to biophysical chemistry, and this is what I'm now doing, or spectroscopy, but this is what I'm now doing. So in my case, it wasn't, but it can be the moment where you realize where your interests lie. So every career is different.
I think the PhD topic was essential for the rest of my career for the simple reason that during this time I started to do computation and computations in a field which were in the field of spectroscopy, which at that time it was not very, let's say, popular. And this opened me the door for investigating further in this direction, also for improving myself, for extending the field not only to chemistry but also to biology. And this is where I'm working at the moment. So I'm working in what I would call, computational spectroscopy. It's a mixture of spectroscopy, computation, and biophysical chemistry.
I stayed in the same field, in the same research area, but not in the same field. So I studied biology, genetics, and then I moved or switched to biochemistry, and also, the methodology changed a lot.
Actually, I switched a lot, and I thought this was actually something very difficult at the beginning, but it was very enriching for my career. So I have a major in physics and material science, and then I did in my PhD in Germany, solid-state physics. I was working in magnetism, so nothing to do with catalysis. But I learned the basic of scientific research. We were also looking at surfaces and looking just at magnetic properties of surfaces. And for my postdoc, I decided that I wanted to do something completely different. I thought if it's not now, then when? And so I took a position in chemical engineering with a joint appointment in chemistry. And this brought me to the field of catalysis. This was when I moved to the United States. And for my first professorship, I went back to physics, but I started a surface science nanoscale physics group.
Which ones were the most critical, or which ones presented the most difficulties during your career path?
I don't remember a specific hard time. I think after having my children, it became more stressful than it was before. But I don't remember like a critical phase. Sometimes when it's on a personal level, it doesn't work out. Then it gets frustrating. But all the things related to science, I never found exhausting or disencouraging. Even though it didn't work out sometimes, but this is normal if you do science.
For me, the most difficult was during the when I had my junior professorship, because there you're already at a stage where you are already in the academia, you want to do research, but you don't know how the future will be.
I think it was then on the process from postdoc to become an independent research leader, and also very difficult was a competition with other scientists. That was really difficult.
So there are two bigger steps. The first one, when I started as an assistant professor, in America it's very brutal start. So you get a lot of resources, but you are completely on your own. And so I saw myself with a lot of money to set up equipment, But then, I had to start teaching in the US, which I didn't have teaching experience. My first classes were teaching 500 people, so this was a challenge. I was teaching physics for scientists and engineers, but the main challenge was to acquire money. So you can have very good ideas, but if you start in America as assistant professor, you can only pay people if you have grants. And getting grants, especially if you are not in one of the top 10 universities in the US, is really, really difficult. Then the second big step was when, after being established in the US and having my research group running and significant funding, I chose to come back to Germany, and I was in Bochum at the Ruhr University Bochum. And at that time, I had to move my research program. I had to start from zero again. So I did it as a full professor, and I had a chair of solid-state physics. But it was very challenging because within 6 months, I also became a mother of twins. So I had to start my group, and then I had to take care of 2 small children. And I think this was probably the most difficult part, teaching, doing the research, restarting the career, and having 2 small babies.
Did you have to make sacrifices for your career, whether it was in terms of family or time?
Yeah, I mean, now I'm a professor in Dresden. My family still lives in Berlin. So I sacrificed several very nice family evenings during the week.
Yes, because also during that time I had both of my kids, so I had to try to keep on doing research, try to keep on doing teaching, and take care of 2 small kids, which is quite tough.
Not really. I mean, maybe my family would say I neglected them a little bit, but I always liked my work, and so I'm not so much a family person. That's why I did not make the sacrifices, but the family, yeah.
Sleep. So I remember that I wouldn't sleep at night, and then during the day I had to go teach and do the research and setting up the equipment. Some funny fact was that my equipment came from the US with a ship the day I gave birth to my children. And I was at the hospital. They asked me if I don't go to clear customs, then they will send my equipment back. So I had to convince someone at the hospital to let me actually leave and then come back. And so I did.
What do you like best about being a professor? And inversely, what do you like less?
I really like the complexity of what we're doing. So regarding the topics, the methods we're looking at, this you can hardly find that in other jobs. And I like to work with mostly younger people who are still very enthusiastic about topics. There's not so much I don't like. I mean, of course, I don't like all these administrative things, but this is not worse than in any other job.
So I would really like to do much more research that I can do at the moment.
I think the best is the interaction with young people, with the students, and also with my researchers in my research group, which is really a lot of joy. And what do I not like so much? I mean, it depends. If when the workload is too much, sometimes the administration, but sometimes it's also fun. And I mean, sometimes the teaching, but this is also fun. So it depends from time to time.
I think the interaction with the students is really very important. The most brilliant moments of my career was when I was at the synchrotron. I do research in user facilities and where you can get X-rays to analyze matter. And I had always participated in these synchrotron trips. My students were there. We will do the experiments together day and night. We will discuss the data. We will do the analysis. And I did this for 10, 12 years, actually until very, very short. And this was really, really important for me and a very good way to get an idea of where are the difficulties and also to be able to tune. Sometimes you find unexpected things, and only if you are there and you do the experiment yourself, you can find out. This is lost when you get larger and larger groups and you have other responsibilities, but this is something that I really enjoyed.
And which parts do you enjoy less?
So writing proposals. I spent in total 12 years in the US, and I had to apply for every penny, and it was really, really frustrating. My success rate was very good, but still, every time that something was rejected, you write a publication, and then at some point it comes out. You write a proposal, and then it's just sometimes you need to be lucky, and other times it's just a frustration if things don't come through. Administrative tasks are also something that I don't particularly volunteer for, so I do what I have to do, but I'm really interested in the fundamental science. And so if someone else wants to take certain committee duties, then I will delegate. I had an experience when I moved to Germany. I was the only woman in a physics department in Bochum. And there are some new laws that you need to have at least one woman in every committee. And if you are the only one, then you start being enrolled in many committees. So you end up with a very high load of administrative commitments. So it was always a negotiation with the colleagues and their understanding that it's not possible to be everywhere. And I think this is one of the problems for women in science, that at some point you also need to learn how to say no to some things that are maybe not as important.
What activities, besides doing pure research, do you occupy most of your time at work with?
So during semester, I would say it's designing lectures, giving lectures. Takes some time. I do write a lot of proposals, manuscripts. These things I like very much. I also spend much time in looking how to finance my people and how to get rooms, fight with the other departments about getting labs or offices and so on. These are the things I don't like so much, but they also, of course, they are a large part of my job.
At the moment, evaluation. So normally what I have to do quite a lot is evaluate PhD theses, evaluate master theses, bachelor theses, papers, projects, and this takes a lot of time because for evaluating something you also have to prepare yourself. It's not that you just write something, you have to know what you're doing. And this takes a lot of time. And of course, bureaucracy.
I think everything takes up time. So usually you have, at the university at least, it's divided in these parts. I mean, 1/3 research, one third administration, and 1/3 teaching, and so it's divided.
So actually, I always keep the time for research because this is the motivation that I have. So if I were only doing, I'm a director of a department now. At the moment, we have 56 people. So of course, there are some administrative tasks, but in the Max Planck Society, we get a lot of support also to make sure that the directors also have this possibility of being really deeply involved in fundamental research. And this is why I took this position. I spend a lot of my time actually writing papers, discussing with the students about the research, and this is the highlight. Of course, you need to do the other things, and there are also tasks that are interesting. For example, outreach is also important, and this is something that I also like to do. But the research is, I would say, takes most of my time at the moment.
And next to all those managerial tasks and administrative tasks that you have to do, how much time do you actually have left for research?
During semester, not so much, because all the faculty meetings, the lectures, the tests, oral examinations, and so on, they take place during the semester. So during the semester, there's not much time left for research, but during semester breaks, there are days where I can work for hours on a research-related topic. So this is nice.
In terms of research, what does your collaboration in a cluster of excellence mean to you, and how has this influenced your research path?
So the cluster of excellence gave me the opportunity or the possibility to cooperate with many people. And it gave me also, or it showed me to see my own research in a greater content. This is very nice. And something I really like is to look for patterns in data or in mechanisms. And this is exactly what this cluster is doing. So I like this concept of this cluster very much.
I think the cluster of excellence is great. It's one of the most important things in my academic career, for the simple reason that through the cluster of excellence I was able to, let's say, also do research in very, very interesting subjects groundbreaking subjects, and also in collaboration with a lot of interesting people, not only interesting but also excellent researchers here in Berlin. Yeah.
As I already mentioned, it means a lot to me, but it's like a family, that's what I say. It's maybe the replacement family, but so I'm in this network already more or less from the beginning, so since more than 10 years, and we are like a family, we fight. Sometimes we don't get along, but then we like come to an agreement and hug up again, and then the collaboration is going on again. So I think it's a really nice network.
So I think it's very important for me. When I moved to Berlin, it was very exciting to be part of a catalysis cluster. I work in catalysis, I work in physical chemistry, and this gives me connections to many excellent scientists in different universities and research centers in Berlin and the nearby area. We get access, I teach courses here for the graduate students within the cluster. This also gives you access to the students. And I very much enjoy being able to talk to people in different fields. So the cluster is interdisciplinary. I think science is interdisciplinary. What we learn over the years is that I'm not a physicist. I was a physicist. I work in chemical engineering. I had experience in chemistry. And the beauty of science is that it doesn't matter what you study, you develop over the years. And this evolution is what you see in the cluster. You see the evolution from people that are in biology, the people that are in chemistry and physics, some engineering background, and this gives the richness of our cluster.
How is your work-life balance?
So I try not to work on the weekends, if possible. I try to have at least one nice summer vacation. And to make time for my family. When you realize you cannot sleep, for example, you are awake during nights and think about work, then you should start to change something, because that is not healthy. I try really to avoid these things.
I would say time management. So when you have the time, when you work. From a certain time, let's say 5 o'clock, you go home, and this is time you stay, you use for your family, and try to not mix one with each other. I think this is the best rule one can follow. And also, weekends are weekends. Yeah.
I think as long as you really like your job, then it is fine. Of course, you always should keep your work-life balance like adjusted or equal, not to work too much, and to see that you, have some private life and enjoy your life. But I think it's good if you like your job.
So I think if you work in synchrotron sciences and you are used to 24-hour measurement shifts, then you learn that you don't need to sleep a lot. So I have compromised by actually really cutting down on the sleep. Specifically now during this Corona time, when the daycares were closed and I had my children at home, you needed to be, I was working at night at the institute, during the day with the children, so you need to be creative. And it's not easy. It requires a lot of commitment, and it takes out that maybe from other hobbies, but you need to make your work your hobby, and you need to make your group part of the family and your family part of the group. And once you achieve this, I think you can do both.
Whether it be professionally or in terms of family, who do you get your support from? Are there specific people in your life, or do you go to external institutions?
I would say that my colleagues are the first people I ask for advice. So my old colleagues here in Berlin and my new colleagues in Dresden. Sometimes I ask people from outside science, like my husband, because he can give a different perspective on.
So if it's professional, of course, my colleagues. I have excellent colleagues here at the Technical University and also outside the Technical University, with a lot of experience in all aspects, not only professional, but also personal problems. And yeah, this is the first contact. And with respect to family, of course, or personal problems, my family itself, or friends.
So for support, of course, my partner supports me a lot. But then I also other colleagues, definitively, also collaboration partners. Yeah, that's also support.
So my first mentor was my PhD advisor, my Dr. Vater in German. This is Bernhard Koine at the University of Duisburg-Essen. And he really took the role of a second father for me. He took me when I was very young, coming from Spain, and he worked in a completely different field than what I'm doing right now. So I'm working in physical chemistry, and he's a person in, so it's the physics, magnetism. He couldn't help me with the science part of the second part of the development of my career, but he was a really important motivator. So we used to speak often when I was in the US as an assistant professor. He even would read my proposals and as an external person and see if an external person could understand this, and we are still in very good contact. And locally here, one of my director colleagues, Professor Robert Schlögel, he has a lot of experience on how to direct an institute, how to direct a department, and also he's a fantastic scientist. So he's my role model to what I want to become.
What do you expect from your university or research institute to support and make the work more attractive for younger scientists?
I think the work itself is already very attractive for a lot of people. It's the framework, the financial framework, that is the problem. That beside the professor, no one gets a permanent position, or just very few people have a permanent position. And this is what does not make this job attractive. So if I could wish for something, I would wish that I would be able to give at least one person a permanent position.
So for scientists which would like to do an academic career, so what I would say, that what the university, but I don't know if it's only the problem of the university, but in Germany in general, is to make the stairs towards a professorship not so steep as it is at the moment. So that there are a lot of other, let's say, steps in between, but which also can assure some kind of financial security. So that people are not afraid of, let's say, staying in the middle. They know that if they don't reach the professorship, you still have steps in between. I think this is missing in our system.
I think Germany has really made a major effort in providing resources in terms of instrumentation. I think also providing access to research funding. This is the reason why I came back to Germany. It was really, really exciting to see that you can do research long term. So the projects you don't plan for 1 year or two, you can have also more long-term projects. So I think this is really excellent at this point here. What you expect is to have the freedom to do the research and also to have students that are really interested in the science. And for that, you really need to be motivating the younger generation. This is one of the reasons why we want to speak in the Science Week, to make sure that we can keep and increase the number of young people that want to stay in science. This is what we need.
I think definitely there has to be, something has to be done to make it more attractive. The young people nowadays, maybe they don't have the passion so much for science, but they definitely look for some stability. And there maybe more has to be done for young research groups than that they also, I mean, there are tenure track systems, positions that they become more, to make that more attractive.
What should universities do to increase or improve the female quote in upper academia or professor positions?
Hire a woman, hire professors. In the end, it comes down to that. You need to hire female professors until you have the same percentage female professors that you have as female scientists.
I think most of the professorships, or the female professors, we all had very similar problems, and this is mostly related with childcare. So I still think that the universities should take care of that, increase or improve childcare facilities, not only for students but also for co-workers. This is essential. And also, I would also say to promote and also to offer much more mentoring programs for younger students, just to incentivize them to continue an academic career and not to be afraid.
I don't know. So I'm working in a biochemistry and biology department, and we have already, a level of 40%, I think, female professors. So there's a problem not so high as in chemistry departments. But it also depends on, maybe on the women themselves, but also, on the society. Maybe there has to be done something. Because at the level of university, we try to hire females as professors, and it is possible, I think.
I think if we think that we can make changes at university level alone, we are lost. The problem is a society problem, and it's much more serious in Germany as in the other two countries where I spent a significant part of my life. In Spain, when I studied physics, it was 60% male and 40% female. When I moved to the US, the quota of female in physics was very low, but much better than Germany still. And I think the main effort is to try to educate the parents and to try to start really from the very beginning in the schools, in the kindergartens, going back to high school, making sure that children get to know what is doing experiments, what is experimental research, seeing that science is something natural. You can use science to explain everything around you. And if you grow up like this from the childhood, then you are going to be much more likely to go into any academic career. At the university, the main thing that we need to do is make sure that we don't make differences. So when we are looking at for applications, we shouldn't be looking at the name or the sex. We should just looking at what are the qualifications and what is the research. Does this fit with what we are interested? And if this fits, then it doesn't matter who it is. And I think we have excellent female and male candidates for many different areas. But to reach to that point, we need to make sure that we get these students to study physics and chemistry and biology, and that's a matter of early education. I don't think you can fix this at university level alone.
What advice could you give the younger generation who are now stepping into the scientific career path?
I think independence is very important, and they should gain independence from very early on. You're never too young or too unexperienced to apply for a certain grant. Even if you don't get it, you can still have a certain experience. But you can be too late for grants. So certain grants you don't get after a certain academic age. And in the end, this is what counts. Not only you need to do good scientific work, but it has to be also on paper your own academic work. So this would be, I think this is the most important advice one should give to younger researchers that want to become a professor.
I would say don't step out, so continue working, because as I said, nature is so complex and the universe is so big that we just know a little bit of this big thing, and there's so much to do at the moment.
Yeah, I think, like your job, the passion of science, that's one big advantage if you have it, and then don't give up easily, and it's a nice job, I have to say.
I think it's probably what I learned from my family, that it doesn't matter where you come from, it doesn't matter, if your parents are in academia. I came from a very normal family, nobody was in academia, but they always told me I can do whatever I want. And I can study whatever I want, and I think I believed that I could do things, and that brought me to Germany. I always had fellowships, so we were not a wealthy family. I could not have studied if I would not have fellowships. And I think the example is that you can just, if you really are convinced on yourself, and this is sometimes harder for women. Many women have a lot of self-doubt because of our personality. So in many cases you see I have excellent female students and I need to give them an extra push to tell them, hey, yes, you can become a professor. I don't have to push as much as some of my male students. My female students, sometimes they have a lot of self-doubt. They are very perfectionistic, and I think this is what we need to try to encourage, that you need to believe in yourself, and then if you have the right interest, you will reach your goal.